Welcome to this video tutorial in which I'm going to program a Thymio robot to be a scratch machine. Let me explain what I mean. So a scratch machine is basically a record on a turntable with the needle in a groove, and the DJ moves the record backwards and forwards and it makes a kind of scratchy sound. I'm going to use the motor on this Thymio as a record, which sounds a little bit strange, but I'm hopefully going to be able to explain what I mean by that. And as I turn this wheel backwards and forwards, what I want to do is make a kind of scratchy noise. Okay, so how am I actually going to do this? Well, of course, normally motors are viewed as being output devices. And normally I'd send a signal, well, in the actuators list here, I've got the ability to, set motor speeds or make the Thymio move forwards. This is the Blockly interface, by the way, for the latest version of CB Studio. But I'm going to imagine instead that my motors are input devices. Now, if you have a look over here on the left-hand side, you'll notice that it says motor left speed and motor right speed. Bizarrely, my left motor here seems to get some kind of bizarre readings coming in here. Nothing's moving here, but I'm getting a negative value, which is a bit strange. But if I was to put the buggy down on this work surface and I move it forward, you'll notice that both the left and the right motors have a reading, and that's because these motors, if you send an electrical signal to them, the motor will turn. So in other words, you're converting electrical energy into kinetic energy, moving the buggy forwards. What I'm doing instead is I'm doing the inverse. I'm going to be applying kinetic energy by pushing the buggy forwards, and the motor converts that kinetic energy into electrical energy, which generates a voltage. Now, I don't know how much voltage this is generating. The number that I'm getting here, which is about 150, 160, that doesn't mean it's 150 or 160 volts. That's just some sort of indicative measurement of how fast the motor's turning. But if I put it on the side here and I just do it with the left wheel, so notice that this is the left wheel of the Thymio, you'll notice the right motor no longer gives a reading, and it's just the left. If I move the buggy forwards, so this movement of the wheel, the buggy's moving forwards, the Thymio moving forwards, I get a positive voltage. And if I make the Thymio go backwards or rotate the wheel this way, I get a negative voltage reading on the dynamo there, on the left motor. So I need to convert this into some kind of scratchy sound effect. Let's see how I might approach this. Well, I need to start off with an event. From my experience with Thymios, both with the VPL, the CB language, and the Blockly, generally things happen with events. And the event I'm looking for in this particular case is that the motor values are being updated. So let's drop that in there. There we are, motor updated. There's a whole bunch of different things here, but that's what I want. So when the Thymio, when the software receives an update to the motor values, something's going to happen. Now, of course, in my example here, because I'm getting this strange reading, actually this event's happening all the time, but therefore I'm going to have to put a little bit of a tolerance in here, and let's do that straight away. We're going to have a logical condition, okay? Here's my logical condition. So I'm looking to see if something is the case. Now, at the moment, it's a Boolean statement. If something is true, I need to change this. I need to change this to if the motor speed, the left motor speed, remember, I'm getting some strange values here. So I'm going to say if left motor speed is greater than positive 10. So if I get any movement on there, it's definitely jumping above 10. So let's have a look here. Can I come to... Let's have a see. Where is it going to be? I need to compare. Yes, I need... Let's have a see. Where's this? Left motor speed. That's what I want. If I drag and drop this in here, look, that's not connecting. So I need to do a comparison of the left motor speed against a value. So let's now come to the logic again, and here's my comparison. Is one value equal or different to another value? Let's drop that in here. Perfect. Now I can drop my left motor speed in here, and I want to see if left motor speed is greater than, and I said 10 was going to be my threshold value, so it's got to be above 10. Okay. Let's make something happen if this is the case. I'm going to make it so that if that is true, notice I've got a little dimple here, and I'm going to set the, let's see, I'll go put the bottom LED, so I'll drop this in here because I'm going to have this turned over like this, and I'm going to be doing this with the wheel. I'm going to have the bottom LEDs lighting up. And let's make them turn red. Okay, so if I run that, nothing happens. But if I run the buggy backwards, look, I'm moving the wheel backwards there, nothing happens. But as soon as I run the buggy forwards, there, it's turned red. Hopefully you can see the red illuminate there. Okay, let's just stop that, and let's just see what we want to do now. Now I'm going to make it so that if we don't run, if we don't activate the wheel, let's make it so the LED turns off and make sure that's working. So let's see, how am I going to do this? I need to add to my conditional statement, and it's going to be, if nothing else happens, then, if none of these events happen, should I say, then I'm going to turn the light off. So let's do that. LEDs, turn off, bottom. Oh, I had that as top, sorry. Okay, bottom left. Okay, bottom left. Let's do that. Sorry, I should have had that. There's the bottom left. That's why it didn't show very well. There we are. Let's run that now. So nothing's happening in terms of my wheel turning. Again, if I make the buggy go backwards, nothing changes. But if I go forwards, that's interesting. Is this running? Now, I'm definitely getting a big value there. If motor speed is greater than 10, set bottom left LED. Is that illuminating? Is it because I've changed this? Let's just change this to top again. Is that going to work? Let's check that out. Yeah, that's working now. How strange, the bottom left LED is not working on my buggy. Let me turn it over and show you on here. There we are, look. Can you see that okay? That's definitely illuminating. So try and make that stand out a little bit more. Let's make that blue. Is blue going to stand out better? Yeah, definitely is illuminating there, but I just don't know whether you can actually see that happening there. You can see it lighting up there on the green surface. So that is definitely working, but it's fascinating that my bottom LED wasn't working. Let's try the bottom right. I want to try and get to the bottom of this. Okay, so this is the one here. This is my left. Is that going to work? Yeah, there we are, look. That's lighting up. How odd. If I stop this and put it to the bottom left. Oh, it's working now. Okay, so there we are. It's only working when I push the wheel to make the buggy go forwards. But that's definitely lighting up. Okay, well, we don't want to make the light illuminate, do we? We want to make it into a scratch machine. So for goodness sake, Mr. Shaw, get on with the job. So let's see what I'm going to do here. Let's stop this. And let's replace, let's do this. Let's go with the actuators. And I want to be playing the sound now. And I'm going to be putting in this right here. And I'll just play this now and see what we get. Now, every time that I move the wheel, it plays a note with a frequency of 440 Hertz, which I think is kind of like, a low Sol or a low G. Something like that, I'm not too sure. There we go. Now, that's not particularly exciting. It's always the first note. And this is now the crucial moment. Modifying this is going to allow me to make my scratch machine. Now, the idea that I'm trying to get across here is the idea of a functional statement. Now, this is in contrast to a conditional statement. So what we've got here, this is a conditional statement. This is saying that under this condition, do that, else do the other. What I want to have here is a functional statement, which means that I'm going to generate a note that's going to be based on a mathematical formula. And that mathematical formula is going to read the value, which is equivalent to the voltage being generated on the left motor, and convert it directly into a frequency. So let's imagine how that might look. So I'm going to say that the frequency is going to be directly related to the, now what's it called here? Motor dot left dot speed. That's what I want to say. So I am going to make it so that rather than playing this particular frequency, well, let's have a see. What have I got in terms of sensors? I have got the left motor speed. Yes. So if I drop that in here, I'm going to play the left motor speed in hertz for 10/60ths of a second, or 1/10. No, 1/6, should I say. 1/6 of a second. Let's see how that works now. Hopefully you can hear that. Now that's pretty cool, okay? But it's not quite the right frequency. So I'm actually going to change this now, and I'm going to say that the frequency is, because at the moment, let's just see why, okay? If I turn this, it seems to go up to about 300. If I do it as fast as I can, it seems to go, oh, I managed to get 700 there. Let's try it again. Yeah, it got up to about, that's quite high, 700 hertz. But I want to go higher than that. So let's see if I can change my function here, my mathematical function, and I'm going to have this 2 times the motor speed. So let's see how I'm going to do that. Let's lose this for a moment, and let's drop in here some maths, and I'm going to drop in this math statement here, and I want to take the motor speed and I want to multiply it by 2. Okay, let's try this now. It's running. I've got that close to my microphone now. And that's pretty cool. I'm liking that. Okay. Well, you know, let's try and make this times 3. Let's see what that does. Well. Oh yeah, I'm getting some really cool scratch there. But when I go back, nothing's happening there. Okay, so what I need to do with this conditional statement here, the original conditional statement, is I need to add in an additional else if statement, which is going to go above the other. So if the motor speed is greater than 10, do this. Else if the motor speed is less than 10, do something else. Else, turn off the LED. So let's just confirm that. Let's see what we're going to do. Let's have some logic in here. Let's have a condition here. So if actuators, no, sensors, motor speed, if left motor speed, no, that should, oh, it's a Boolean condition there. That's no good. I don't want that. Let's put it in the bin. That's true or false. Let's have a see. Logic. Yeah, that's what I want. It's some variables. If left motor speed is less than -10, then we can do something different. So just to get the ball rolling here, all I'm going to do is I'm going to drop in an LED here, and I'm going to set the bottom left to be something that's going to stand out, I hope. When we see it, let's go with green, on the camera down the bottom right there. So let's just run that, and let's just see what we get now. So if I go forwards, it's illuminating in blue, and I get the sound. If we go backwards, it's illuminating green, but I haven't got the sound yet. Okay, so that's working fine. So I'm not going to go any further with this in terms of the actual programming, because you can see the format I'm looking for here. But there's just something to consider up here in terms of the actual mathematical function I'm going to be using. Okay, and that's because when I'm going backwards, I'm getting a negative speed. Now, in terms of a negative speed, does that mean I'm going to get a negative frequency? I don't actually know. I mean, mathematically that should be the case. And if I get a negative frequency, is that still going to play the right note? So something that you might want to do here, frequency, if I can spell it might be helpful. Okay, I'm going to modify this, and this is for motor forward, and this, there we go, this is going to be for motor backward. Cool. Okay, so here I'm going to say it's going to be equal to, and this is going to be the difference, I'm going to multiply it. When it's going backwards, I'll have a negative motor speed. Therefore, I'm going to multiply it by a negative value. Now, is that necessary? As I say, I don't know. Maybe the software will play a negative frequency. But if not, if I want to make it positive, if I multiply a negative motor speed, because remember, when I go backwards, this generates, here we go, I'll do it right now. If I go backwards, I get a negative reading on the motor. If I multiply a negative reading by a negative multiplier, I will end up with a positive frequency. So that will be a modification that I will have to make to this functional statement for when the motor speed goes less than negative 10. Let's see if you can complete that. Now, as an extension to this, we can do a few other things. You could make it so you could change the function here so that the frequency does some different values. You could make it so that depending on the speed the motor's turning, you have different light colors being generated. Just check this out very, very quickly. If I come to the LEDs, and I've been setting the LEDs to a fixed color, well, I can also change the LEDs to a variable color based on a value between 0 and 32, where 0 is off and 32 is fully illuminated. So could you make it so that you can control the light, the color of the light, depending upon the intensity or the pitch of the sound, which again is controlled by the speed of the motor being turned. So there's a few nice little extension activities for you to do there. You might even want to make it so that both wheels do something funky, and then you could put the Thymio down on the table here, and you could actually move it around like this. And as you move it around, not only the lights change, you also get the frequency change as well. So, have fun with that. See you soon.